Welcome to Make Maharashtra, my educational video channel. Previously we have discussed about Reynolds equation and Petrov's equation. Now the third scientist had explained about this sliding contact bearing parameters. The scientist name was Raymondies and Boyed. So they were the scientists and their method is Raymondies and Boyed method. So here Petrov, he has explained about the frictional torque. Reynolds, he has explained about the three parameter: pressure gradient, velocity gradient and flow rate. But the Raymondies and Boyed, they had explained the process of finding the parameter which are dimensionless. There are few dimensionless parameters they have defined, and they have suggested these dimensional parameters you can consider sliding contact bearing. So first parameter they have suggested, that is Sommerfeld or bearing characteristic number, and that is indicated by S. Sommerfeld or bearing characteristic parameter, that is Sommerfeld number, they had explained. Now what is this Sommerfeld number or bearing characteristic number? How to define this bearing characteristic? So in that they have explained that S is equal to R divided by C bracket square mu ns by P. This is dimensionless parameter. So R is the radius of the shaft, C that is journal, C is the radial clearance, that is capital R minus small r, mu is the absolute viscosity, ns is the speed of the shaft, and P is the bearing pressure that we have calculated. P is nothing but W by area. In case of the Sommerfeld, P is the bearing pressure, that is W by load by L into D, that is length and diameter of the bearing. So that they have defined. Now the Sommerfeld number is calculated by this way. Second parameter they had explained about the length to diameter ratio, L by D ratio. So theoretically they have suggested length and diameter of the bearing should always, L by D should require 1. Here next parameter they have suggested about the thickness, that is minimum oil thickness with respect to clearance. Now eccentricity ratio, that is generated by the eta E by C, eccentricity with respect to C, and this equation we have derived. Capital R is equal to, from the nomenclature, E plus R plus HO. R minus R is nothing but C, that is radial clearance, divided by C for every term, will get eccentricity ratio plus HO by C, and which value is eccentricity is equal to 1 minus HO by C. So this will be the oil film thickness, or HO by C is equal to 1 minus eta. Likewise we can calculate. So this will be the oil film thickness with respect to eccentricity ratio. Next parameter they have explained the coefficient of friction variable, CFV, generally noted by CFV, and it can be indicated by R by C into F. So these are the direct formulation they have given by Raymondies and Boyed, and through which we can easily calculate the values of the sliding contact bearing parameters into F. F is nothing but coefficient of friction. Next one is a flow variable, FV we generally consider. So flow variable, in case of the flow we will have to consider Q. Capital Q is the flow rate of the lubricating oil divided by RC ns into L. R is the radius, C is the clearance, ns is the shaft speed, and L is the length of the bearing. Next parameter, flow rate, that is QS by Q. QS means what? Supplied flow rate, that is in case of the hydrostatic bearing, and Q is for flow rate. So that ratio we can calculate directly. Then maximum film ratio, that is pressure ratio, P by P max, initial pressure and maximum pressure. Next will be the positional maximum film pressure. This can be calculated, theta P max directly given generally. Then zero pressure angle also directly given. Then this is a very important temperature rise variable. So this can be calculated TRV, that is rho Cp into delta T divided by bearing pressure. Rho means mass density, Cp is nothing but the specific heat of lubricant oil, delta T rise in the temperature of the lubricant oil, and small p that is the pressure we'll have to consider here. So these are the general Raymondies and Boyed parameters which they have explained. First one is, I'll revise, Sommerfeld number, which can be calculated by S is equal to R by C bracket square into mu ns by P. Second is L by D ratio. Then third will minimum oil film thickness. Fourth one is the eccentricity ratio, eccentricity divided by clearance, and next one is a eccentricity ratio is equal to 1 minus HO by C, or HO by C is equal to 1 minus eccentricity ratio. Coefficient of friction variable R by C into F, flow variable Q by RC into L, Q by RC NS into L, then flow rate QS by Q, pressure rate P by P max, zero pressure, and TRV, temperature rise variable, rho Cp delta T by P. Rho is density, Cp is the heat, delta T temperature rise, and pressure. So these are the basic Raymondies and Boyed equations. Here is very important, only one type of numerical in this chapter, only one type, and that depends on the Raymondies and Boyed method, correct? Now this kind of the chart they will give in the exam. All the numerical, all the formulation they have given, all the parameter formulation. See, this is the table for Raymondies and Boyed. What they have mentioned: L by D ratio, how much? HO by C, oil film thickness with respect to clearance, eccentricity ratio eta, S is the Sommerfeld or bearing characteristic number, then R by C into F, that is control flow variable, and then flow variable Q by RC NS into L, flow rate QS by Q, and pressure range P max by P, or most of time P by P max, whatever be the given in the table that you need to take. So this kind of the table they have mentioned: L by D ratio for 1, infinity, 1 by 2, 1 by 4. So we will have to check as per the length of the bearing and diameter of the bearing, then you will decide L by D, and then we decide which L by D ratio we need to focus. Clear? So this kind of the chart will be available directly in the examination. The numericals are straightforward and depends on this pan. They will ask you calculate Sommerfeld number. You can directly, and no need to calculate also. If they have given the table, I can say suppose L by D ratio 1.1 by 2 and HO by C is 0. So S is 0. From the chart we can easily define the parameters. Okay, I hope you understood the things which I told you in this session. Next session will temperature effect of the sliding contact bearing. We'll see in next lecture. Thank you.